Good afternoon and welcome to a conversation on the future of mobility, specifically focused on V2X and where we have been. Just to set the stage, our GDP from transportation is about $2 billion annually, moving goods, people, and services on about 4 million miles of roads with over 200,000 intersections and close to 300,000 traffic signals. What if we created a secure and intelligent network that connected everything? Intelligent transportation system will transform the mobility ecosystem globally through vehicle to anything or everything communications, also known as V2X. Vehicles can exchange data with all other entities, including other vehicles, pedestrian, traffic, signals, road signs, work sites, the grid, and potentially many more fixed and mobile devices. This connectivity loop between the vehicles and between vehicles and infrastructure is performed through communications with dedicated sensors in the vehicles. The communications are performed either through a dedicated short-range communication protocol, which is an IEEE 802.11p Wi-Fi based protocol, also known as WAVE. In 1999, the FCC allocated 75 megahertz of spectrum in the 5.9 gigahertz spectrum for this particular purpose. The other means of communication is through cellular V2X, another protocol developed for a connected and autonomous future, defined by the Third Generation Partnership Project. CV2X utilizes cellular radio instead of WAVE DSRC. Cellular means simply a SIM card in the telecom network. In other words, your phone. Starting in 2010, following rigorous testing in various countries, notably Japan and the US, certain feature sets were deployed in select vehicles. And by 2015, Europe and China joined Japan and the US in deploying such capabilities on a road. The most recent deployment of a Society of Automotive Engineer Level 3 vehicle was in Japan by Honda earlier this year. The first such deployment of a tipping point functionality, getting close to autonomous driving. The difference between DSRC and CV2X, because of the cellular network, allows you to have indirect connection between the cars as well as certain distance advantages through the CV2X. To put it bluntly, we were at the 10-yard line in a global competitive landscape with momentum and wind at our back. With COVID and the recent FCC ruling and order, potentially having the spectrum available through DSRC, we've been stuck at the 10-yard line. And we need to move quickly to regain the momentum. Markets dislike uncertainty, and we need to eliminate such functions. So why should we care? Well, we should care because V2X is foundational for autonomous vehicles. Safety, speed, congestion, volume, pollution, transit deserts, improved access, inclusion is all part of a feature that is available to us if we can get the system together. Digitizing supply chain logistics and providing options can be part of that future. However, the scale, speed, and viability of a DSRC or CV2X, or even a 5G CV2X ecosystem build-out is currently challenged by uncertainty across the regulatory, technology, and market landscapes. V2X is about system of systems, testing, proving, and unlocking a market. It will take the federal government, together with states, counties, and cities, and the innovation from the private sector to impact, as I described earlier, a multi-billion-dollar ecosystem. We can do this. Today, we have a panel of experts who will tell us the story of where we have been, what it takes to demonstrate the future, manage a complex ecosystem, and deliver innovation. I am Rahul Gupta with Deloitte, and I lead our smart infrastructure practice and offering. 32 years in the business, both in the federal government and the private sector, at the intersection of technology, innovation, and transformation, and I'll be your moderator. So let's get started. Our first panelist is Megan O'Callaghan. She is the City of Dublin's Deputy City Manager, Chief Finance and Development Officer. Previously, Megan served as Dublin's Chief Operating Officer responsible for the management of the citywide infrastructure and day-to-day service delivery. Megan graduated from The Ohio State University with a bachelor's degree in civil engineering. She also graduated magna cum laude from Capital University Law School, where she earned her Juris Doctorate. She's a member of the Mid-Ohio Regional Planning Commission. Most importantly for us today, she's also a member of the Northwest 33 Innovation Corridor Council of Government Board, and is appointed to the State of Ohio Board of Registration for Professional Engineer Surveyors. Our second panelist today will be Jim Katsapanis. Jim is an Associate Vice President and Assistant Emerging Technologies Program Manager with Michael Baker International. His engineering consulting expertise includes traffic signal system, intelligent transportation systems, connected and automated vehicles, technology deployment, and transportation system management. Most importantly for us today, he's a voting member of ITS America's Smart Infrastructure Standing Committee and a standing member of the TRB. He's also overseeing the 33 Smart Mobility Corridor, including the infrastructure design, system engineering, and roadside onboard unit development. Finally, second to last, we have Vijay Narula, who's the founder, president, and chief executive officer of OST Global. He has deep experience in the field of aviation, having worked on several programs for the FAA in Washington, D.C., some of which focused on spectrum engineering and management. He's also worked on essential elements of cyber protection. To this day, he's responsible and focused on smart technologies, including the deployment of such technologies as the newly inaugurated Stafford Smart City Testbed. Finally, we have Simon Zhu, who's a manager with Deloitte's government public sector practice focused on intelligent transportation, mobility, and smart infrastructure. He has led smart corridor engagements across Florida and Arizona, where he facilitated the development of multimodal ITS initiatives. Simon is also currently Deloitte's PM for the ITS Roadmap Initiative in support of the 33 Smart Mobility Corridor. He's part of ITS America's Future of V2X and automated vehicle programs. Welcome to all, and to do proper justice to your background, I would recommend those listening online to please ping our panelists on LinkedIn. So with that as a background, let me get the conversation going. Megan, can you tell us about the 33 Smart Mobility Corridor? Why did the COG want to embark on this journey? And what does this ecosystem look like? As we demonstrated, it will take a large village to get us going.
Thank you very much. I'm happy to be here today. I would be happy to provide some background. The 33 Smart Mobility Corridor is located in the Beta District, which is a uniquely situated region where the private sector, government, and academia work together in an open playground to safely test and deploy technology in real-world scenarios. Specifically, the Beta District is an economic development area. From Dublin through Marysville and up to East Liberty, we have 35 miles of US 33 Smart Mobility Corridor connecting the three entities. The Beta District also reaches all the way down into Columbus, Ohio State University, Center for Automotive Research to make a larger smart mobility ecosystem in the Central Ohio region. This area has one of the highest concentration of college students in the nation, 134,000 students. 18,000 auto-related workers, 7 times more engineers than Vegas or Ann Arbor, which are peer-connected vehicle regions, and 25% R&D related workforce. So one of the things that makes the Beta District attractive is that we have several strong industry clusters. And as you can see on the screen, this is just one example of an industry cluster. We have more than 70 automotive companies located in the Beta District, and along the corridor, along with the Transportation Research Center, Ohio University, and the Ohio State University. We also have manufacturing, healthcare, aviation, and insurance clusters that also exist in the region. And we know that people in R&D like to cluster together. So we are definitely aware of the unique attributes of these clusters, and we are using that to leverage what we already have going to continue to expand those clusters and attract businesses to the area. So if you could switch to the next slide, please. The Beta District is a building region where private sector, government, and academia all work very well together in an open playground to test, deploy technology. We're definitely talking about providing real world scenarios along the corridor in the cities of Dublin and Marysville. We have tremendous partnerships which provide a very unique environment that's made possible by all the collaboration of business, academia, industry, government partners, including the cities of Dublin and Marysville and Union County. So you can see on the screen, we are very close partners with ODOT. They also have DriveOhio arm. We have Ohio State University. We have OU, Ohio University. And then we also have Honda located towards the end near Marysville and in East Liberty. You could go to the next slide, please. A little background into the COG, which is the Council of Governments. So in 2016, the Council of Governments was formed between the cities of Dublin and Marysville and Union County. And the purpose for forming that partnership was to work together to promote economic development in the area and along the corridor. So very quickly, we applied for a grant and we quickly were successful in receiving a $5.9 million grant from the U.S. Department of Transportation for the deployment of fiber being installed along US 33 between Dublin and the Transportation Research Center in East Liberty. And then ODOT also pledged another $16 million for the fiber installation. So we have 432 strands of fiber installed along 35 miles of US 33. There's also roadside units installed along the 33 Smart Mobility Corridor and at signalized intersections within the cities of Dublin and Marysville, and we'll be installing onboard units in vehicles as well. So what we've done is we've leveraged our proximity and relationships with Smart Columbus, DriveOhio, which I mentioned, and they are a statewide initiative that organizes and accelerates smart vehicle and CV projects, as well as our industry clusters in the region. So the 33 Smart Mobility Corridor is part of an even larger Columbus region connected vehicle ecosystem, as you can see on this slide. Next slide, please. So while the first few years, we had a primary focus on implementing the grant project. This above ground technology will enable testing, data collection for connected vehicles and autonomous vehicle research. We're working hard to make sure that the world knows that this ecosystem is about more than mobility. It's more than connected cars. It's really an economic development platform, and it's a workforce and talent driver and also recruiter. So it's about promoting smart workers and an open collaborative place for training and testing. Next slide, please. Within the Beta District, we have the 33 Smart Mobility Corridor, which I discussed. We also have Connected Dublin, which includes all of Dublin, Ohio's initiatives to leverage existing and emerging technology to improve lives, drives, and experiences for Dublin residents, corporate citizens, and visitors. And then similarly, there is Connected Marysville, which includes all of the city of Marysville's initiatives. So I hope that that provides a good amount of background and insight into our economic development strategies and how we're leveraging the 33 Smart Mobility Corridor.
Absolutely. Thank you, Megan. I love the slide that basically showed all of the automotive and industrial partners that you have along that corridor. That just goes to show you that nothing happens in isolation and it really needs to come together. So Jim, maybe you can walk us through how you've handled that complexity, especially when somebody changes the technology behind the scenes, or somebody tells you to go sharp left or sharp right and you were going straight. What's been the experience implementing the ConOps?
So I can tell you, Raul, there's been a lot of sharp lefts and rights in the project, that's for sure. As Megan mentioned, this is a federal ATC MTD grant. So we had a limited budget. The grant itself ended up being somewhat of a wish list of, things, sub projects, deployments, applications. So I think one of the very first things we had to do at the onset of the project is really get an understanding of what some of the problems were that we wanted to try to solve. So looking at it from a safety, congestion type of problems, and then working with the stakeholders to kind of develop what those user needs are and how we're going to solve the real world problems that are out there. So we had to go through what we called we decided to go through what we call an application readiness assessment. And that essentially was a scan of status of all different types of V2I applications, whether they were in the grant application or not. We wanted to get an understanding of, are they conceptualized with just only high level system architecture to have they been done in proof of concept? Have they been piloted? To have they been included in real world deployments? So what we wanted to do is really, to meet the goals of the stakeholders, we wanted to, and really the budget itself, we wanted to have a good understanding of what striking that right mix of applications, which ones were ready, which ones required some development under the project, and having a mix of those so we could, make sure that we deployed something that would be practical for everybody, and something that we could build upon. So another element of, I think, of the ConOps was we wanted to make sure that we demonstrated interoperability. So we wanted different configurations of equipment, onboard units, and that was something that was very important. We have a whole host of, we actually have 4 entities, government entities that are part of the COGS. So, they're all going to be supplying either roadside, roadside locations for devices or vehicles for equipment. So that was something that was important, that interoperability was met on this project. But when we did get to, the actual deployment, I think Megan had talked, a little bit about what we've done already. We've deployed all the infrastructure on 33 to make continuous coverage on 33. That was something that was important to the stakeholders, that we could have continuous RSU coverage point to point along the corridor. So that's 35 miles of RSU coverage. That includes poles, power, cabinet, and the fiber connections to that. We also have deployed 63 DSRC units and configured them and partially tested them on 33, and then 29 it signals in Marysville and 12 in Dublin. We also have a back-end network, an infrastructure management system, a GPS correction system. We've also integrated into ODOT statewide security credential management system. And then lastly is planning for the applications that we're going to be deploying on the onboard vehicles, onboard units in the vehicles. And that's 4 applications plus planning for 3 future ones that are in the ConOps. But in terms of the deployment itself, I think the impact of the FCC ruling, that we've been talking about for well over a year or 2 now, has had some significant impacts to the project. First and foremost is we were caught in the middle of the FCC decision. We had started deployment, we had started our work, and things were gray for a while. And so we were kind of caught in the middle of, we've already invested dollars into the deployment, and we really decided to stay the course for the most part and move forward. But we had fully intended this to be a DSRC system. So in fact, our readiness assessment was based on known data points of these applications and how they operate in the entire spectrum in the DSRC environment, not in a C to V2X environment. We also had located the poles based on continuous coverage, based on a DSRC environment. And then ultimately, the other impact was the significant delays in the project in terms of licensing. So we had put out, we had requested licensing for the entire spectrum initially. That was denied. Even though it was at the time where the notice of proposed rulemaking, the first one was still in action. So those were denied. We further revised it to an experimental license at the direction of the FCC, or guidance from the FCC. That was not approved. So we've ultimately had to make the shift to a channel 180 only deployment. And we've now had to issue a change order to our integrator to reconfigure the equipment and reconfigure the equipment to allow us to operate in the reduced spectrum. But what we really don't know is, how is that going to operate in the 180 channel, 180 only spectrum? We don't know from an interference congestion standpoint. We no longer have the ability to have separate channel plans developed for adjacent RSUs, for example. But I think the benefit of this is that we can give us an opportunity to provide a testing environment for those to come and test that can really try to do this in a real world environment under a limited channel configuration.
Thank you, Jim. I think that just shows the complexity. It's not one thing, it's many things, and the key role that spectrum plays and how multiple agencies are engaged. And clearly you have integrators and you have providers. So Vijay, that kind of set the stage. You helped inaugurate this new test bed in Stafford. You just heard from Megan and Jim, who have been at the forefront of exploring and implementing for the benefit of society. Can you give us a sense of how you're addressing some of those known issues, and how would you address some of the unknown issues, especially when we're talking about a system of systems approach?
Thanks, Rahul. And I think Megan set the stage up correctly for what's going on there, and then followed by Jim as to the issues around the spectrum. And it's always realized, like Jim mentioned, they applied for the license, were denied, then they applied for the experimental and it was denied. Spectrum has always been left out as an afterthought. And I'll come back to why that's an afterthought and why it should not be at the forefront of as we move forward. So as we are aware, OST as a company has been supporting the FAA in the area of spectrum management for the last 30 plus years. And out of the 62 years that FAA has been around, spectrum is the most, worried about asset, is the most precious asset in the nation has, is spectrum. And it's highly utilized, it's congested, and we're always worried about the new innovations coming in and causing interferences. The times of the old warfare are gone. Now it's about the digital warfare, which means warfare on the spectrum front and what it can have an impact on the society and the community. So for OST, that has been at the forefront as a spectrum as to the interferences, the congestion, as to what happened. So when we were looking at V2X, we looked at it from saying, it's a complex machinery that is networked with many sensors and a real-time decision-making system. And we're expected to have these in billions, if not 50 billion, 60 billion, the number, take a number. The devices that are supposed to be connected are in billions. It's no longer a few 100 million here or there. And that is the impact that we need to be very careful of and plan for as we deploy the system, not only by local, state, federal level, but globally. Because what we are doing in one area is going to have impact globally. So obviously the stance that everyone's beating their head on with the FCC ruling and the DSRC versus the impact that they're trying to do with the 75 megahertz, the 30 megahertz up front, trying to separate that for safety, has always got concerns. And where does the FCC align? And under the Chairman Pai, we have been having discussions with him from the spectrum perspective as to what is it that really can be approved in a transformative manner of not taking decades to approve. Earlier, what we had done was, we would run, like OST was one of the companies that actually did the study for the 502, what we call Wi-Fi on planes. And how long it took us from just doing the engineering studies on it to the actual deployment and approval of implementation into the aircraft. So same thing we had to do from all the angles that we are looking at from the transportation side. We're looking at technologies from, can we really identify radio frequency, the various bands on the spectrum that the multiple technologies that are yet to be developed will be using or being called upon for use on FCC. And that in turn has to be collaborated and coordinated with the NTIA, which is the governing body for the federal side. So the fight between the NTIA, what the federal government is doing versus what FCC is doing, and the license that it does, and in the manner that it does, is very critical. And that's what I believe that where it really comes up to the industry is to step up and propose the various solutions, like Jim has talked about the collaboration. It's been an uphill battle for us. But I think one thing that FCC is doing is selling spectrum now, is making sure we release some of the additional spectrum that can be made available for various modals of transportation. And I think that's what we need to look as an industry to see what spectrum is becoming available and how that can be leveraged in the coming years to reuse or reassign for other use case in the smart mobility perspective. Now, obviously, V2X, we're looking at sensors from vehicle to vehicle, vehicle to infrastructure, infrastructure to pedestrians, and as we go in from urban mobility to rural mobility. So it's a mix of use of spectrum and what really works. And one thing we have been always fighting for at our side is the use of 5G. And really, what role can it play? And can we really get certain bands in there that can help us align for the safety perspective of V2X or even CV2X? And so we are looking at various aspects of that band 5.9, saying, can we propose new transformational solutions to FCC from an engineering study perspective, saying, earlier we had all analog channels. Now we have digital channels. Now, can we really refine or go to our manufacturers of the equipment to say, hey, can you refine to use certain channel, co-channel, adjacent channel, to bring in what we need is to deal with the various devices that are going to come up in our infrastructure to provide interference-free platform for communication. Now, none of the V2X can work without wireless communication. We can have infrastructure that's wired, but at the end of the day, it is wireless communication that's going to provide us the autonomous vehicles, short range, long range. And what we are looking at is autonomous vehicles, not only from the perspective on just on the road, but we're also looking at UAMs, urban air mobility. So that is another complexity that we're looking at, and at that level where they're flying below 400 feet is an issue for us, where we are looking at competing with, we're calling it autonomous vehicles still. So how does spectrum fulfill everyone's need on the ground, above ground, and above in the air, the NAS? So when we are looking at from OST's perspective, and we were rolling out and we launched the test bed in Stafford, which was done by the Commonwealth of Virginia with CIT, we really aimed on bringing in the users of spectrum, the federal government, including the FCC and NTIA, and getting their feedback as to what studies are they conducting in the next year, 2 years, 3 years, 5 years, and aligned with the political referendums that are being passed to push FCC and NTIA to take a certain direction, to support the demand of the industry for this. So we have been aligned with that, saying what is coming up ahead and saying, hey, what tools does FCC need? So our assignments, frequency assignments they're called, our licenses, requests that come in are done in a timely fashion, and they can be engineered to provide an interference-free environment. So we are creating a suite of tools for the federal government at this point to look into the 5.9 gigahertz engineering and saying what modeling and simulations can be conducted to say, if you were to operate within a certain environment, zone A, or a certain expense on the highways, what impact will it have on the national infrastructure? Meaning other things that are operating on 5.9, plus minus co-channels, everything. I'm not going to get into the technical aspect of it, but it's really creating that model, collaborating with the industry, with the nonprofit organizations that are working on this big issue, is to collaborate with the federal government now, not tomorrow, and put in our thought process, the white papers that we have, the engineering that is going on, and the new solutions we are developing today for tomorrow. We need to give the government the heads up on what is really needed now to plan for tomorrow, to release the spectrum and give the spectrum to the manufacturers and the integrators to develop and launch these solutions.
Yeah, so that sounds very much like we need a roadmap. And so Simon, this is the perfect setup for a question: how does a potential V2X and an FCC decision might look like that would not only help US 33, the beta districts, and the likes of gyms who are now tasked with addressing complexity. And you just heard from Vijay that we need to be very clear, not take decades, right? So maybe you can walk us through in terms of what that looks like for us.
Yeah, thanks, Rahul. And let me just start by saying I really like what I just heard just now, from Vijay around the importance of partnerships across various levels to bring forth that future of innovation. It's in the spirit of that partnership that we've joined together with our colleagues at the COG and Michael Baker to support their objectives for the 33 Smart Mobility Corridor, and builds off of the experience that Deloitte has been doing for a number of years, supporting large test beds in places like Hillwood, Texas. So during the course of our engagement, we spoke with a broad set of stakeholders across the 33 Smart Mobility ecosystem, OEMs, testing facilities, academia, standards development bodies, federal as well as state and local entities. And the overall takeaway is that, this test bed is really at the heart of this incredible ecosystem that in many ways represents what the future of transportation could look like. But how do we get there? How do we help the project and their partners turn on the test bed? But more importantly, how do we help them keep it on? And so it's with that framework in mind that we set out to design a roadmap that helps navigate the changing operating environment for ITS over the next 3 to 4 years. And I'm going to present my screen. I don't know if you guys can see it.
Yep. There you go.
Perfect. So what you have here is the roadmap for the 33 Smart Mobility Corridor, providing a decision framework. And really the three environments that we're talking about are the current environment, which is still under the 75 megahertz shared, the reduced environment for the 30 megahertz, beginning with the first RNO becoming effective just later on this week, and with a 1 year anticipated date. And then for the 30 megahertz spectrum for cellular V2X operations sometime in late 2024. So the roadmap accounts for several variables that anticipate the dates for when changes to spectrum or technologies take effect, what the market availability for CV2X devices look like, and also the cost and licensing considerations. And really what you have here is a framework that looks at 3 decision points. The first is getting on the spectrum. The second being the transition towards the mixed standard environment with both DSRC and CV2X. And then the third being operating in a CV2X only environment. With the first decision, getting on the spectrum, this builds on what my colleague Jim said earlier about getting channel 180 licensing to get approved by the FCC. The reason for this is because there's a better chance of getting the license approved sooner than would be the case for 75 megahertz. This is a strategy that's been adopted successfully by a number of municipalities, including Columbus, who have chosen this as an alternative to the extended wait time experienced by some for approving for a full 75 megahertz license application. The second decision is around the transition of DSRC towards a mixed standard environment. And so this really comes after the anticipated second RNO sometime in late 2022, which we hopefully provides some clear guidance on not only the CV2X operations in the 30 megahertz, but also on the potential sunset period for DSRC. The benefit of going the dual mode approach is that it allows for testing in DSRC to continue while gradually phasing in the CV2X testing. And then as testing familiarity with CV2X devices and applications grow, there's an opportunity to introduce the 5G new radio devices into that environment as well. Finally, in the third decision point, is sometime in late 2024, when we anticipate that the ITS operating environment will transition to a full CV2X only environment. By this point, it is our understanding that the project will have had at least hopefully a couple of years testing CV2X devices, both 4G and 5G, to inform what would be needed for a system-wide implementation to continue sustaining operations over the long term. The value of this framework, we believe, is in its flexibility. There's different levers that can be pulled that either accelerates or decelerates the pace of transition based on the regulatory updates of when certain milestones are announced, as well as on market signals for the maturity of various devices. In other words, it lets the project choose the best time for those actions over the next few years. Most importantly, we believe it helps overcome indecision by comparing some of the trade-offs associated with a potential sit and wait approach versus taking action. And we recognize that while there are uncertainties ahead, the dangers of not taking action are arguably greater than moving forward in the near term. So with that, back to you, Rahul.
Thank you, Simon. I think as I was listening to everything that's happened since 1999 and some of the first car certain technologies and certain devices, it really speaks to the bottom line. You need to deploy it on a physical site. You need to test it out. And there's an entire economic discussion behind it. So Megan, back to you. You've heard now from the panelists, how does a potential roadmap, a decision or indecision support some of your aspirations? And specifically, how does the COG and the Beta District keep delivering to the citizen Ohio and indirectly to the country in terms of the capability and the functionality as a result of some very good decisions that have been either laid out in this roadmap or have been highlighted by Vijay and Jim?
Sure. So getting to a decision really is key. Working through the regulatory complexities and getting that switch to be turned on for the connected vehicle environment is really critical to our vision and strategies for the Beta District, as well as our overall economic development activities and the viability of the Beta District region. With over $100 million of investment in the smart mobility corridor thus far, I would say that the stakes are high and all the government, industry, and academia partners will only accept success. The fiber and connected vehicle environment is really the foundation to all the activity in the region and will provide that real world environment for safe testing, which is key to our mission. As Jim discussed, the FCC ruling did insert a real challenge and brought about a lot of questions and unknowns as to the future of the corridor and all the initiatives. So we're excited to work with Deloitte team and all of our partners to identify and vet all the options to bring our CVE online so that we can promote our live environment, launch more initiatives, and see the fruits of all of our investments and time and energy to this point. So when you ask about the link to the Beta District, it's really much more than that. It's about achieving the ecosystem that's really at the core of what the Beta District is.
I think that is really key, because if one was to take the time to learn about how a product is put together, a car, a truck, and what will go into that entity, the vehicle itself, it takes hundreds of companies to kind of come together. And it's very much true in terms of delivering that on the ground. So Simon, what role does partnership play? You just heard Megan talk about hundreds of millions of investment, and it's no one entity that can succeed. Maybe you can talk a little bit about the value of partnerships and making sure that those test beds are truly that example.
Yeah, thanks, Rahul. I think from some of the discussions that we've heard earlier today between our colleagues in Ohio and Virginia, it's clear it takes a village not only to stand up these test beds, but also to operate it over the long term. And over not only to submit some of the grant applications to get the test bed funded initially, which requires its own level of partnerships and cooperative agreements at the state and local level, but also, various partnerships between the public sector and the private sector. What I liked about the examples, on both the 33 Smart Mobility Corridor, broader beta district, and also what I'm hearing in Stafford is that, that partnership has been, that theme of partnership has been infused from the start, from the initial ConOps design all the way to the implementation. And so there's that institutional knowledge that continues, and that really, the power of those relationships between the various players, the decision makers, the policy makers, and the implementers, help ultimately determine the success of some of these test beds.
Yeah, so thank you, Simon. And we've got, probably 8 to 9 questions that have come in. And so I'm going to weave some of those questions and get comments from Vijay and Jim. Vijay, you are very familiar with FCC and Spectrum. I recall my days of working with the Joint Spectrum Center and the NTIA and the FCC when I was at the GAO. How have you incorporated the fact that there is an uncertainty in building your use cases in Stafford? How have you ensured that you are able to deliver the test bed and generate the value that can be then translated into operations? Can you give us a sense of how you have taken that complex system and maybe working with Stafford County, made sure that it doesn't stop because somebody's made a decision that's going to take years?
Thank you, Raul. Just to give a reference to where this test bed is, Stafford County is located between DC and Virginia, and DC and Richmond, and it's on the 95 corridor. So it encompasses at least 16 miles of I-95 in the thruway. And this is where the Stafford downtown is, and it's one of the upcoming counties in this area where the Quantico base is, and there's Army base on there and a couple of other classified bases in this county. So the whole idea, like we talked about and Simon said as well, it's all about the collaboration and making sure all the entities are on board prior to the kickoff. And that's why there was a lot of, it took us almost 1.5 years to get all the stakeholders. Started with the governor of Virginia, then came up with the CIT, that the sponsoring organization, then came in Department of Homeland Security at the federal level, DOD from the federal level, and then came in FAA for the airports in that county. So we had a lot of stakeholders coming in and saying, what is it really that we want to achieve here? And what are the use cases that we really are important to us we want to try to come up in a short while? So this test bed was to look at the new technologies that were coming up and were being able to implement in an integrated fashion. So everyone said, we have these new solutions coming up, but they're working in silo. They don't integrate with each other. They don't talk to each other. And there's a lot of effort that's going on. So we said, okay, we need to create a platform where we are doing true interoperability between the various solutions. We're talking about this. When we talk about the solution set, we're talking about sensitive, confidential, and classified environments where we know the information or the data being exchanged is coming from a secure environment. So we set up this thing, okay, our infrastructure has to be robust. It has to be interoperable. So just like Simon came up with a plan, same thing, we came up with a plan, a roadmap as to what really needs to be and what are the top 3 or 4 use cases that'll come up. So we came up with almost 150 use cases from all the stakeholders saying what's important, and they all agreed to the top 15. And I'm going to talk about just a few of them today to just give you a relative as to what it involved. So one was obviously the IoT platform. As you know, the information coming in, whether it be the ITS, whether it be the public safety, whether it be the security, the communication layers, and making sure we had a communication platform. So we're going to focus on those 3. And we realized that what we needed was a public-private partnership. We did not need one person giving money to the other. We do not want to depend upon it. It's all the partners coming in from the industry, at the state level, at the FFRDCs, the R&D side of it, and obviously the government, the federal and the state and local. So when we brought all these organizations into one platform, which we call public-private partnership, we really saw great success. we saw a lot of collaboration going on, and people were taking proactive actions as to saying, okay, this is what we're hearing, this is what we're saying, and then moving forward in that fashion. So this led to funding coming from multiple avenues for us. It was not just DOT, it was not just FAA, it was not just DHS, or DOD or the Marines. So we had stakeholders coming in and putting their requirements, and all of them had the need. They had the same need, surprisingly. So what number one use case was the IoT platform with true interoperability. Second was a secure environment. Given what we had going on, cyber security with a zero trust framework was very critical to ensure whether it's a device, whether it's a machine, whether it's a vehicle, whether it's a sensor, like you said, 100 sensors maybe in a car. Can any of them be exploited to point the wrong data set that we need to make decision making? So that was a big thing. So coming up with the zero trust framework was number two. Then 5G was number three. We wanted a platform that could actually take the data exchange at the speed that we wanted it to, and really have real-time decision making. And we wanted to make sure that 5G was basically, in this case, and embraced by all stakeholders, including state and local. There's a lot of hesitancy into the impact of the 5G on the community and what its impacts are. Same thing with the federal government as to everything. So we brought that in as well. And then the last fourth thing that I want to touch about is use of drones. And use of drones is becoming a major impact on anything that we do, whether it be ITS, whether it be on the emergency services. So we went with the drones, use of drones for public safety. So all four for us, not only did the test lab where we were bringing in technologies for testing, we have able to deploy them successfully in less than 18 months. And I'm talking about not as a pilot. We started as a pilot, but they've gone into full-fledged implementations. IoT platform is being used by Stafford and by Arlington County. Cyber Zero Trust Framework has been implemented at the Stafford County and in used by the Stafford County buildings. 5G network, indoor and outdoor, has been implemented in the courthouse and the government buildings in that area. And drones are already being implemented by the Sheriff's Department for the public safety in that area. So what we are trying to do is now take that evolution and saying, what is it really that we need to create the next level of impact on saying this is a smart community or smart environment in that area, is we are building a now smart town center for Stafford. And that has really come in and bringing in all the now, not only the rules, the regulations, the policies, the standards have all come in play now to take these four solutions and put them into implementation stage and scalable. So we have made these scalable solutions that are actually being implemented. And we are looking at now from this perspective is saying ITS on the I-95, what does it require? So that's a very heavy segment of the 95 that's always backed up. What are we doing? How are we using the use of drones? How are we using the sensors? How are we using, what kind of sensors are being implemented? And how does that, so those feeds have started coming in, the data. So we are providing a platform that not only collects the data, stores the data, allows the analytics, does the AI ML on the cloud. And one thing we have added is the decision support system that to actually help the citizens or the travelers to make it implementation-wise successful implementation. So for the spectrum perspective, yes, we are fighting for the licenses. We have been able to successfully get it because we had preempted all the simulation modeling. Our studies had been done prior to us going to FCC and NTIA saying, hey, we plan on doing this. And we had the licenses request being sent by the government rather than entities. So we had the DHS request of license from the FAA because we knew the process, or to NTIA to go through the IRAC committee to get us the license that we needed for experimental purposes and limited geographic area.
Thank you. That's great. And just like yourselves, Jim, a question to you. You've been engaged in multiple test beds and deployment of connected and testing of autonomous. Maybe you can talk about your experience nationally and some of the lessons that can be synthesized so that when we think about V2X, not just as an experience or an experiment, but something that needs to be deployed at scale to address some of the issues of congestion and safety and fatalities and pollution. Maybe you can share what you have gleaned so far and what everybody should keep in mind.
Sure. I mean, I certainly can share quite a bit of lessons learned, but if we really want to talk about a little bit more about the safety spectrum and some of the impacts, lessons learned there, I think, and then CV deployments, nationally, and, I think we can share that, system engineering, is a very, very vital component of anything we do, any deployment. And that documentation really needs to be a living document. And in the case of the safety spectrum, when we change course, this makes it much easier for us to go back and make sure that we've dotted all our I's and crossed all our T's and reducing the risk of the deployment. That's something that's very important. And when we need to change over to C-V2X in the future, this is really for anybody that has an existing DSRC deployment. As you switch over to C-V2X in the future, if that ends up being the best course of action, I'm not suggesting it is at this point in time, but if that ends up being the best course of action, you really have good documentation of what you did, and it helps you facilitate that switchover. I think a couple of the other things too is, as we deploy CV technology, you really need to plan the significant time and resources for verification and troubleshooting. This isn't, it's a mature technology. But it's been limited. It's got some limited deployment. So, there's standards are still being developed. Standardization is still being developed. So we really have to spend the time and the resources necessary to verify and test and troubleshoot issues. And then I think lastly, as we've proven on our 33 Smart Mobility Corridor project, is really expect the unexpected. That is first and foremost. Maybe I put that third, but I think that is, a big issue, is we have to expect the unexpected. So in the case of our project here, that we've been talking about, the FCC decision on the 5.9 gigahertz, we have to consider what this future CV2X deployment looks like. What's that impact to contracting, vendor or contractors that you would have on board to do those switchovers, what your maintenance and operation agreements look like, what is that interference might look like for unlicensed Wi-Fi, channel congestion, sustainability of your investment that you've already made. Really, those are some things that I think that are unanswered, and honestly, we don't have a lot of answers for all that. So I think we could add a lot of things in a year or two when more deployments are starting to get some of these answers on these things.
That's great. And I know we've got about 5 minutes left, so if I may ask each one of you to take just 30 seconds. From my vantage point, I think the most important activity anyone can undertake is, if you're going to make the investment, make the effort, and deliver a new capability, functionality that is beneficial to society. How do you measure it, and what is the time frame that takes to do that? So a quick question in 30 seconds. Do you see SAE level 3 or equivalent deployed in the United States in the next 3 to 5 years? And if you could answer that yes or no, or maybe, and then maybe just add your perspective of what is missing to make that happen. Jim, may I start with you?
Sure. In the next 3 to 5 years, I don't think we'll see the maturity of it yet. I think that there's a lot of things that still need to be answered. There needs to be some standardization with things such as the HD mapping. There's some things that I think that we still don't know, answers we don't have, but those tests are ongoing. So it's not to say that we won't have the deployments, but I think anything full scale, we're still a little bit off on that. What needs to be done? I think a little bit more standardization, understanding what the needs are from the infrastructure standpoint. I think we've missed that a little bit. It's not just deploying automated technology without consideration with the infrastructure and what's needed from the infrastructure.
Thank you. Vijay, your turn.
I agree with a lot of what Jim said, but I think we'll have pockets of these implementations where we'll see CV2X being implemented and rolled out at certain level. I think it'll take some time, like he said, of over a few years as we make it broader across the country.
And I will change my question for Simon and Megan. Simon, are we seeing the type of partnerships that we need to make the 3 to 5 years a reality?
I think so, Rahul. And actually, I want to maybe blend the last question and this one together, because I do think, there are pockets where AV, specifically, for level 3, there are pockets where that's happening, but that's uneven. Some OEMs have chosen to pursue level 3. Others have chosen to skip ahead to level 4, level 5 altogether. And I think a big issue around that is the human factors. What's the transition between machine to human takeover in a vehicle when you're sitting in a traffic jam versus, when the human driver is ready to take back over. And there's still ongoing debate around that, as well as continued research and testing. But then also, I think a big part of, the partnership aspect will also need to focus on getting human acceptance of technology. And that's really demystifying both the challenges and perceived risks with riding in an AV, and that can be accomplished through partnerships between local municipalities as well as OEMs and industry to provide demos for the public to kind of alleviate some of those concerns.
Thank you, Simon. Megan, US 33 is one of the crown jewels in the DOT investment. There are other cities that have received federal grants and investment to demonstrate that technology. What would you like to communicate to us that we either didn't cover or is important in your role to ensure that this investment keeps delivering for the benefit of all?
Sure. So I know I sound like a broken record when I keep talking about the importance of partnerships. But I can't say enough about the partnerships and the strength of those partnerships that we have in the Beta District region. 6 years ago, I never would have imagined that we would have over $100 million of investment in the 33 Smart Mobility Corridor. And look where we are today. We've made so much progress, and it's all attributed to those partnerships. And it's with the cities, academia, 2 large universities, and then also with the state. So I'd just like to thank all those partners and relationship for all of their efforts. And I just think that's key to all of our success, and we can accomplish whatever we set out to accomplish.
Thank you. I'd like to thank ITSA for organizing this webinar. I want to thank my panelists. We covered an extremely complex topic that is complex across multiple federal agencies, multiple state agencies, multiple cities, and it really stitches a variety of technologies to deliver a new capability. We're on the cusp of truly changing the way we move and why we move and digitizing our supply chain logistics. Watch this space for additional insights, and I look forward to continuing this conversation, just like for the last a year virtually. So thank you very much. Thank you to our audience, and have a wonderful 4th of July.